this video, we will be talking about gravimetric analysis. The learning objective for this video is to learn to apply these stoichiometric relationships to calculate amounts of substances involved in chemical reactions. So what is gravimetric analysis? Gravimetric analysis, you can think of the word gravity. We are going to be precipitating out a reactant in order to calculate how much there is. This means we'll weigh a filter, pour our stuff in that's now a solid, and then analyzing how much of this solid we collected. So subjecting this to a precipitation reaction. Through some fancy mass measurements like before and after, we can use the masses that we calculate in order to figure out how much of the compound we're interested in was in the original sample, or what it was. So here's an example of this analysis. It says, consider a 1 gram sample containing 75% potassium sulfate and 25% of another metal sulfate. Sample is dissolved and barium nitrate is added to precipitate all the sulfate ions as barium sulfate, because barium sulfate is insoluble in solution. So it's going to pull out all the sulfate ions from the potassium sulfate and all the sulfate ions from this other metal sulfate as a solid. And we weigh the mass of the solid as 1.4900 grams. And then it says, what is the identity of the metal cation in this unknown metal sulfate? Now, let's see what we know. So we know these two pieces of information, which can tell us what our mass of potassium sulfate was in the solution. So we have 1 gram times 75%, and that will be equal to 0.7500 grams of K2SO4. So we know our mass of that. We know that our mass of this metal sulfate has to be 1 minus that. So our mass of the MSO4 is going to be equal to 0.2500 grams, because it's 25% of 1 gram. So we know our mass of both. I also know the molar mass of this, so I can calculate how many moles are due to this compound. So I have 0.7500 grams of potassium sulfate, and I can convert that into moles using the molar mass. Because when in doubt of what to do, go to moles. So if we convert this to moles, we'll know that that is equal to 0.004304 moles of potassium sulfate in the original sample. Let's go ahead and store this number. Okay, so now let's figure out what else we know. It says the sample's dissolved and we're precipitating, and then we know the mass of the precipitate. And so from that, we can figure out how many moles of the sulfate ion there were. So we have this many grams of barium sulfate. We can convert that into moles of barium sulfate by using the molar mass of barium sulfate. And the molar mass of barium sulfate is provided, and that is 233.39. So 1.4900 divided by 233.39 And so that gives us that number. But let's just be clear that that is also the mass of the sulfate, the moles of the sulfate ions. This is using the subscripts in the chemical formula. So, not like a balanced chemical equation, but one of this formula unit contains one sulfate ion. So we're just pulling that out. Can't really make out that. That was a 2 minus to indicate sulfate. So this is equal to 0.00638 for moles of sulfate total. This, if I took it a step further, I could have also inserted that same type of conversion factor where I have 1 mole of the potassium sulfate and that contains 1 mole of sulfate ion. And so this isn't just moles of potassium sulfate, this is moles of sulfate ion that were part of my potassium sulfate. So subtracting these two numbers should give me how many moles of sulfate ion came from my unknown. So if I take 0.00638 and I subtract that gives me 0.0020800 moles of sulfate ion from my unknown sample. And from that chemical formula, I can see that it must have been a 2+ cation, because for every 1 mole of sulfate ion, there is 1 mole of the unknown. There's only 1 sulfate in that chemical formula. So that tells me that I have that many moles. Let me erase this real quick. Okay, so I rewrote my moles of this metal sulfate, and I know the grams. Now, this gives me enough information to calculate the molar mass. We know that molar mass is equal to grams per mole. And so that is 0.2500 grams for every 0.0020800 moles. So we have 0.2500 divided by 0.00208, and that tells me that my molar mass of my unknown is 120.19 grams per mole. That has a chemical formula of MsO4. I can calculate the mass due to the S and the 4 oxygens and subtract that out. And so I can subtract out the molar mass of SO4. Subtract out the mass of sulfate. And so 1 sulfate is 32. Here, let's hit clear. So we have 32.06, and then we have 4 oxygens. And so we're going to be subtracting out 96.056 grams per mole. So we have 120.19 minus 96.056. Ah, I didn't hit clear. And so my molar mass of M is equal to 24.134 grams per mole. And according to the periodic table, that is magnesium's molar mass, or at least extremely close to it. And so that matches magnesium. So I rewrote it nice and clear, and by matching that to the periodic table, I can see that my metal was magnesium. Here's a practice problem for you. It says a 10 milliliter solution containing chlorine ions was treated with excess silver nitrate to precipitate 0.4368 grams of silver chloride. What was the molarity of the chloride ion in the unknown? Go ahead and pause the video and unpause the video when you are ready to continue. Okay, so we have this many grams of silver chloride. Let's go ahead and figure out how many grams or how many moles of chlorine ions that was. Since it's asking for molarity of chlorine ions will be equal to my moles of chlorine ion divided by my liters of solution, which in this case would be the 10 milliliters. So I have to calculate the moles of chlorine ion so I can proceed forward. And we can get that from my silver chloride. And we are given the molar mass of silver chloride up here. So we have 143.321 grams of silver chloride for every 1 moles of silver chloride. .43. Why does it forget to clear on this digital calculator app? Or always forget to hit enter to make sure it knows I'm done with the calculation. I'm just going to go ahead and make sure that I know that this is chloride ion. So based on the subscripts in the chemical formula for silver chloride, for every 1 silver chloride, I have 1 chloride ion. So this is indeed 0.0030477 moles of chlorine ion. I'm asked to find molarity, so I'm going to have to convert that to liters. So molarity will be equal to 0.0030477 moles of chlorine ion, and then to get to liters, I have to divide by 1,000. So that is equal to 0.0. That's 3 bumps. Yep. So I got to divide this number by 0.01. And so that tells me that my molarity is equal to 0.30477. And I need 4 significant figures, 1, 2, 3, 4. And so that will be, that's an arrow, 0.3048 molar chloride ion.